These are the Math 1340 College Algebra 5.3 Graphing Polynomial Notes. We're going to start with page 1. We'll see how far we get in this recording. We need to continue what we talked about with quadratic functions and make sure we understand how those basics apply to functions when there are higher degrees. So, quick warm up here. This would be a good time to pause the recording. Make sure you are comfortable with some of these fundamental skills that we will be using. And I'll see you back in a couple. So first off, A. I don't have 3 terms. I'm not looking to factor into 2 binomials. So I'm going to start by looking at what I can factor out of both terms. 3 goes into both. 3 times x gives me 3x. 3 times 6 gives me the 18. B, same thing. I'm looking for what I can factor out of both terms. Sorry again. 2 goes into both 2 and 8, so I know I can factor the 2 out. First term has an x to the third. Second term has an x squared. So I'm going to factor out that 2x squared. 2x squared times x would give me the 2x to the third, my first term. 2x squared times 4 would give me my 8x to the second, my second term. C, I have 4 terms, so I am going to start by grouping. I'm going to group the first 2 together. I want to make sure I put a plus between them so I don't screw up my signs. And I'm going to attach that minus to the 9x, negative 9x minus 27. I can factor an x squared out of the first 2. Oops. Gives me an x plus 3. I'm factoring a minus 9 out of the second 2. That gives me an x plus 3. I get x squared minus 9 times x plus 3. I can factor this difference of 2 squares into x minus 3 times x plus 3. And if I want to be as concise as possible, x minus 3 times x plus 3 squared. D, I cannot factor anything out of all 3 terms. So I'm going to start with the easy part. The only way I can multiply 2 terms and get 2x squared, where they both have an x, is 2x and x. Now I need to figure out how to factor the 6. So when I multiply something times 2 and something times the 1x, I get a difference of 1. I'm going to go with 4x and 3x, x plus 2, 2x minus 3. Okay. 2, just a little different. We're being asked to solve. So we are going to start by factoring, but I do want to point out I got an x to the 4th here. So I am going to, just so it looks better, I'm going to do a substitution. And I'm going to rewrite this as w squared minus 5w plus 4 equals 0, only because that makes it a little easier to see how we factor. That becomes x squared minus 4, x squared minus 1. Both of those are a difference of 2 squares. Well, I'll highlight this a different color. The x's that make that true are positive 2, negative 2, positive 1, and negative 1. So fourth degree polynomial, we have 4 solutions, which typically is how it works. Should have as many solutions as the degree of the polynomial, the highest power. Now, they're not always going to be real numbers, but it gives you an idea of what you're looking for. Okay. So when we talk about polynomials, we start by factoring, doing what we did above. That gives us the x-intercepts. Okay. The x-intercepts we find by looking for the x's that make y equal 0. Okay. And that is this part down here. And I'm highlighting it in the same color because that's what we just did above. We found those zeros. Each of those zeros, and this graph does not go with above, has an x-intercept that goes with it. Because what we found were the x's that make y equal 0. The y-intercept is always fairly easy to find, also fairly easy to find. The y-intercept is the point where x equals 0. Okay. That gives us a general shape of our polynomial. We're connecting the dots. Okay. We have something called turning points. The turning points are where our graph changes direction. Okay. So we've talked about the intercepts. Here's our turning points. A turning point is a point where the graph changes direction, either increasing to decreasing. So we're going from going up to going down, or going down to going up. And in pre-calculus, when we're talking about increasing and decreasing, we are just looking at the graph. Where is the graph going up as we read from left to right? Where is it going down? Yeah. You can take the time to read through these notes. I am not going to read them for you. I will color coordinate so you can match with what we talked about above, how to find the y-intercept, how to find the x-intercepts. And now, we don't always have x and y. So we're going to work through example 1 here. We have a polynomial function t of n. It's already factored for us. The n is going to be our input, right? These are our x values, if you're super used to x and y. T of n, this is the t when n is a certain value. This is the fancy way to say, what's my y? What's my output? Okay. So we're going to start by finding the t-intercept. That occurs when the input is 0. So basically, we're looking for our vertical intercept, our y-intercept. And just so we're mathematically precise, I'm writing this as t of 0. What do I get when I plug in 0? My t of 0 is 8. So when I plug in 0 for x, I get 8 for y. And if we come down here to the graph where it's already graphed, I stuck that in there so as we go, we can confirm we're doing this correctly. The n-intercepts occur when the output is 0. So again, here's my function. T of n is n minus 2 times n plus 1 times n minus 4. I want my output to be 0. The only way I can multiply numbers and get a 0 as an output is if one of the factors is 0. So n equals 2. I should have spaced a little better. When n is 2, t is 0. I got n plus 1 equals 0. N equals negative 1. When n is negative 1, t is 0. And I've got n minus 4 equals 0. N equals 4. When n is 4, t is 0. I got negative 1. I got 2. I got 4. I can connect the dots, but I can always double check. If I multiply my first 3 terms, coming back up here to my function, I got n times n times n, 1n to the third. My leading coefficient is positive, so I know I should be going up to the right. So I am connecting the dots, which matches what I've got here. Arrows on the end means it keeps going on. It doesn't end just because my graph has ended.